Welcome geometry students to the homework help video for page 269, numbers 3 through 17. Please have out your homework, please have out your books, have your calculators, pens, pencils ready, and whatever else you need, and let's go ahead and get started. Occasionally my voice is a little raspy, and that's the case today, so please understand I will be clearing my throat a good deal today. Let's go ahead and get started. First of all, let's look at numbers 3, 4, and 5. The directions say, explain how to show that the statement is true. Explain how to show that the statement is true. Okay, let's go ahead and get started with this first problem. I'm not 100% sure, but usually in these situations, it's a pretty wise idea to go ahead and split the two triangles up. And I'm doing a very sloppy job, but that's okay. And there we go. Okay, now watch carefully what we do here. We have VSU and SUT. Now angle STU, I'm going to put a 1 there, angle 1, call that angle 1, and angle UVS, we'll call that angle 2. So angle 2 right here, okay? Angle 1 and angle 2. Now, how can I show that these two angles are congruent? Well, the only way to do it, students, is to prove that these two triangles are congruent, okay? And once I prove that these two triangles are congruent, then I can definitely state that this angle here is congruent to this angle here, because remember, when two triangles are congruent, their corresponding parts are congruent. So here's what I have so far. Please look carefully. I have a parallel line cut by a transversal. Do you see that? And we know that alternate interior angles are congruent. So this angle right here is congruent to this angle right here. Okay? Now, this is a pretty tough problem. I'm not sure if I'd give you one of these on a test or a quiz, but nonetheless, here it is. Now we have this line here, parallel to this line here, cut by this transversal right here. And again, alternate interior angles are congruent, okay? So that means this angle right here is congruent to this angle right here. Not easy to see. You might have to back the video up 2 or 3 times, but that is the truth, and that's how that works, okay? And then notice the two triangles share this side right here, so this side is congruent to this side. So how can I state that these two angles are congruent? Because I know that triangle VSU is congruent to triangle TUS by what reason? Well, you tell me. Angle, side, angle congruent to angle, side, angle. So that's the reason why, okay? I go fast on these because you can back them up, okay? Those that get it quickly can move on. Those need to back it up can back it up. All right, number 4. How can I state this right here? How can I state that AB is congruent to DC? Well, again, let's break out the tracer. I think it's always, I'll try to do a little neater job this time, a little better anyways. I think it's very important to split your triangles up. I really do, okay? I think it's very important. Pull this down here, I guess, and over a little. And this one here, okay? Let's quickly label what we have. We have an A here, and a B here, and a C here, and we have a B here, a D here, and a C here. Now look what they give us. They tell us that this angle right here is congruent to this angle here, okay? This angle right here is this angle right here, and this angle right here is this angle right here, all right? Now, we also know this angle here is congruent to this angle here. Now, the only thing I can see, do you notice how they share this side right here, BC? Both triangles have this side they share. So I know that I can state BC is congruent to BC. Now, let me pull this down a little. So how can I state that AB is congruent to DC? Because look, these two triangles are congruent. How do I know that? Well, look, angle, angle, side, congruent to angle, angle, side. So I can state that triangle A, B, C is congruent to triangle, to match it up. A has 2 slashes, so D comes first over here. B has no slashes, so C comes first over here. Excuse me. And then C has 1 slash, so B has 1 slash over here, so B goes next. And there it is. What's your first 2 letters? AB. What's your first 2 letters? DC. AB is congruent to DC. What's the reason? How do I know these triangles are congruent? Angle, angle, side. Mr. Earhart, I really don't know what to put for my answer for 3 and 4. Just write stuff down like this. Just prove to me that you know what you're talking about. Okay, let's get out a tracer again real quick. Let's trace our 2 triangles and split them up. Let's see, this is the one that would be there, and this is the one that would be, did not want to do that, that's for sure. There we go. Alright, now be careful as you mark these. This is the triangle right here. That is here, here, and here. Okay? So we call that M, N, L. And this triangle right here is this triangle right here. That triangle right there is this one right here. Okay? So we have J, L, K. Now watch your angles carefully. This angle right here is this angle here. This angle right here is this angle here. This side NL is right here. And JL, let's see. No, right here. KL is right here. There we go. Now, do they share anything? Oh, you bet they do. Most definitely. Both triangles share this angle right here. One triangle comes down like this, and the other triangle comes down like this. They share that angle right there, angle L. So if they share that angle, that means this angle right here has to be congruent to this angle here. So look what you have. Angle, side, angle, congruent to angle, side, angle. So I can state that triangle MNL is congruent to triangle, now letter M came first, no slashes, J has no slashes over here, so J comes first, N is second, N has 1 slash over here, K has 1 slash, so K comes second, L is third over here, L has 2 slashes, L has 2 slashes over here, so L is here. So now, I'm trying to state that angle J is congruent to angle M. Well, what's first? M, right here. And what's first over here? J. So there you go. Angle M is congruent to angle J. And by the way, how can I state that these 2 triangles were congruent? Angle, side, angle. Okay, moving on to number 6. Number 6 says, showing congruence. In the diagram, triangle JKL is congruent to triangle PQR. Why can you conclude that K is congruent to Q? Well, I think it's very, very obvious. I'm not sure how to put this in words. I mean, what is your second letter right here? K. What is your second letter over here? Q. So, I mean, I really don't know how to answer this. I think it's a pretty decent question, but I guess you would say because of the congruence statement. The second letter is K, the second letter is Q, thus they have to be congruent. Oh, maybe I know what they're looking for. Maybe they want you to put this. Why can you conclude that? Maybe they want you to put this. Congruent parts of congruent triangles are congruent, CPCTC. That's probably what they're looking for, because as soon as you know that 2 triangles are congruent, the way that you can state this is because of CPCTC. That's probably what they're looking for. Okay, moving on to numbers 7, 8, and 9. The directions read, tell which triangles you need to show are congruent in order to show that the statement is true. So we're basically doing the same thing for 7, 8, and 9 that we just did for 3, 4, and 5, basically. Okay, so here we go. Very quickly, as always. Did not want to do that. I was trying to keep the answer somewhat secretive. All right, there's your two triangles. This would be A, C, B. This would be C, B, D. All right, notice we know this side is congruent to this side, and this side is congruent to this side, and notice they share this side here. So this side is congruent to this side. So we know that triangle ACB is congruent to triangle, now let's see, AC has two slashes. We want to be careful here though. We have to make sure that the angles line up with the correct angles here. So let's see. A is an angle here that has a 2 slash and a 1 slash, and D is an angle here that has a 1 slash and a 2 slash. Do you see that right here? 2 slash and 1. So D comes first. Next we have C. Now C is formed right here by a 2 slash side and a 3 slash side. So over here C is formed by a 2 slash and a 3 slash. So C comes next. So obviously the only letter left is B. So what triangle do we have to state? We have to state the triangle ABC is congruent to DBC. That's the same thing I have. Notice they just swapped these two letters here, but they also swapped these two letters here. So it's the exact same thing. I just have ACB, DCB. They have ABC, DBC. Same thing. But here's what you need to state. And once we know these two triangles are congruent, then we know these two angles are congruent. A is congruent to D. And what's the reason that we can state these two triangles congruent? Side, side, side. Okay, number 8. I'm not going to split these because you can pretty much, they're just touching at a vertex. We know that vertical angles are congruent, so I know this angle here is congruent to this angle here. Okay, so what I have is side, angle, side, congruent to side, angle, side. So I know I can state congruent triangles by side, angle, side. I'm going to start with my top triangle. Triangle JKL is congruent to triangle. Now, J came first. You see that? This angle right here is formed by a 1 slash side and a no slash side. So I've got to find an angle down here that's a 1 slash and a no slash. It's right here. Here's 1 slash. Here's no slash. So angle J lines up with angle N. Okay? So if J is first here, N is first here. All right. Next is K. Well, K is formed by a no slash and a 2 slash side. So here's a no slash side and a 2 slash side. So K goes with M. K goes with M. So here's K. M is next. And then, of course, L would have to be last. So J congruent to N. J right here, congruent to N, so we're good there. How could I state these two triangles were congruent? Side, angle, side. And so what two triangles do I need to state were congruent? Triangles JKL congruent to NML, and there it is. Okay, let's take a look at one more. Number 9, I think it'd be wise to go ahead and split these two triangles. There we go. All right. Now let's see. We have A, C, B, A, C, B, and this would be F down to D over to E. Now, wow, what do these triangles have in common? Let's see. Do they give us anything at all on these? We know that, let's see. I paused the video and I looked this problem over, and I don't mind saying when I've made a mistake. I think I probably did 7 and 8 a little too much detail by giving side, 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 and side, angle, side. As I read the directions again to myself, it does just say to show which triangles need to be congruent so that this statement is true. It does not say we have to know why. They just want to know what two triangles you would state. And I really do mean that. I'm not making an excuse. Now, maybe it is possible to prove that these two triangles are congruent. Maybe it's not. But as I read the directions, they just want us to state the triangles that would need to be congruent so that we can say this right here. So for me, it's going to be triangle ACB congruent to triangle, okay, I went ACB, so over here it's EFD. EFD. All right? And then we got it, DE congruent to BA. Well, here's DE, and here's BA. So if you wanted to prove that this was true right here, then you'd have to state that these two triangles here are congruent. Okay? All right, let's move on now to numbers 10, 11. Sketch the overlapping triangles separately. Mark all congruent angles and sides. Then tell what theorem or postulate you can use to show that the triangles are congruent. Okay, fair enough. This should be relatively simple. Let's go ahead and split our two triangles. All right. If we can, maybe we can't do that. Let's see here. There we go. And there we go. All right, here we go. This triangle here would be B, then over to D, then down to C. And this triangle would be the letter B, then over to D, then down to A. Now, they tell us that BC is congruent to DA. So here's BC, here's DA. They also tell us angle ADB, this angle right here, is congruent to angle CBD, so CBD. So there we go. Now, do you see any parts they share? Sure, right here. They both share BD. So we know that BD is congruent to BD. So students, how could I state that these two triangles are congruent? Well, it looks like side, angle, side, side, angle, side, congruent to side, angle, side. So there's the answer, side, angle, side. Okay? All right, let's go ahead and take a look at number 11. Let's separate the two triangles. All right, here we go. Let's go ahead and get rid of that right there. And let's see this triangle right here that goes from E down to G, E to G, over to F, and back up. So this would be an F. And this triangle here is the one that goes from here to here to here. So H, J, G. So H, J, G. Now they tell us E is congruent to H, so 1 slash here, 1 slash here. EF is congruent to HJ, so here's EF, here's HJ, okay? So, do these two triangles share anything? Oh, students, of course they do, definitely. Look, they share angle G. I mean, one triangle comes down like this and goes up, the other triangle comes down like this and goes up. They both have the same angle. So I know angle G here is congruent to angle G here. So let's see what we have. How can I state that these two triangles are congruent? Well, it looks like I have angle, angle, side. Angle, then an angle, then a side. Angle, then an angle, and then a side. So yes, I can state that these two triangles are congruent by angle, angle, side. Let me grab a drink of water. And let's go ahead and continue on. Number 12. The directions for 12 and 13 state, what theorem or postulate can you use to show that the triangles are congruent? Well, here we go again. It's basically the exact same thing. So you know what? You might be falling asleep, but you're getting a lot of practice. And I'll tell you what, there's few things that replace practice. Practice is very important. The more you do this, the better you'll get at it, okay? So there. I have tried to split the two triangles. Hopefully successfully. Now let's go ahead and label our triangles. Looks like one is A, then up to C, then over to B. The other is D, then up to F, then over to E. Now, we know this angle here is congruent to this angle here, and we know that this angle here, which is this angle right here, is congruent to this angle here, which is that angle right there that's marked. And then we know this side here is congruent to this side here. Well, students, we're done. I mean, here it is right in front of you. How do I know these two triangles are congruent? Well, it's angle, angle, side. Angle, then an angle, then a side, congruent to angle, angle, then a side. So there's your answer. How do I know these two triangles are congruent? Angle, angle, side. All right, number 13, let's go ahead and, oh, we got quite a few triangles here, don't we? What do they want us to copy? I think they want us to copy this here to here to here, and then this one from here to here to here, I think. We'll check that in just a second. Make sure we're right. That's a really bad triangle, isn't it? Let's try to straighten that out a little bit really quick here. Just make it a little more like a triangle. Or maybe it's worse now. Anyways, here we go. This triangle here would start at H. It would go down to J. No, I apologize. This triangle right here is this triangle right here. H to K to M. Okay? Sorry about that. So it would be H to K to M. And I'm just going to make this much sharper. There we go. H to K to M. And then this triangle right here, that one, would be this one here, H to J to G. So H, then J, then G. Now, we know this angle right here, which is this angle right here, is congruent to this angle here, which is this angle right here. And we know this side here, JH, is congruent to HM, so we know that. And then students, do you notice how both triangles share? This triangle here has this angle, and this triangle here has this angle. They share angle H. They really do, okay? So I know this angle here is congruent to this angle here, so there you go. Angle, side, angle, congruent to angle, side, angle. So how do I know these two triangles are congruent? Angle, side, angle. And now down to 14. These are not my favorite things. I am not a fan of these. I give them to you, fine, whatever, but I am not a huge fan of these, okay? We'll do these very quickly. I don't think you'll ever see one of these in a test or a quiz, I don't think. Okay, number one, I've stated AB is congruent to AE. Notice that's in your given right there, so I'm going to go ahead and erase that. And that is, let me fix that real quick. And that's your given. Now notice step two, the reason you wrote this blank right here is given. Well, we already wrote this right here in your given, so what you wrote over here must be angle ACB congruent to angle ADE. It's your given. Now, look over here. They want you to use the reflexive property. That means, you know, A equals A or AB equals AB, something like that. Well, if you're going to use the reflexive property, look for something these two triangles share. Now watch what I mean here, okay? Look, this triangle right here has angle A, and this triangle right here has angle A. So the two triangles share angle A. So I'm assuming right here what they've probably put is angle A is congruent to angle A, reflexive property. Now, and I don't really want to get into drawing all of this separately. I really don't. I probably shouldn't have given you this problem. I just don't really care for these. The triangle ABC is congruent to AED by angle, angle, side, because you do have a congruent angle here, and then a side right here. and then you have an angle, angle side because this other side is congruent. Once you state the two triangles are congruent, now listen, this part you should know. Once you state the two triangles are congruent, then you can definitely state that the corresponding parts are congruent. Here's B, second letter, here's E, second letter, so you know that B is congruent to E, B is congruent to E, and you should know the reason. CPCTC, corresponding parts of congruent triangles, are congruent. Okay, I went through this fast. Please just move on. This is not one I want to focus on. I probably should have skipped it. The main ones I want to focus on now are 15, 16, and 17. These are the ones you probably don't want to focus on, but these are the ones I want to focus on. So again, you're seeing more and more proofs. If I'm not going to give you a lot of these on a test and quiz, we've got to do them in class, so you're seeing them over and over and over. Okay, the directions say to prove that the statement is true. Now you're used to seeing, now watch this, students, you're used to seeing given, right? And they tell you something is given. Well, they kind of helped you out. Instead of writing out what the given is, they went ahead and put it on the diagram for you. Okay, so that's good, that's cool. We can handle that. I love that, actually. So here's what we're trying to prove right here. We're trying to prove angle A is congruent to angle C. Now, here we go. Step one, you pick up your given and you put it on the triangle, on the drawing. Well, that's already done for you. Step two, we're going to go ahead and put our statements and our reasons chart up here. Put an S here for statements, R for reasons. And then next thing I've told you to do is write your given. Well, Mr. Earhart, there is no given. Yeah, but it's on the diagram. Like right here, AD is congruent to CD. So AD congruent to CD. That's given. What else is given to you? Let's give this angle here a number. Let's call this number 1. We're going to call this number 2. I don't mind you doing that on a test. So I'm going to say that angles 1 and 2 are what? What are they? Right angles. And of course the reason for all of that would be given. So do you see where I got the given from? Do you see this? It was given to you in the picture. So this is your given right here, and I know that I know that because it's on the picture right here. Now let's brainstorm, students. Come on, let's brainstorm. How in the world can I prove that angle A is congruent to angle C? Well, the only way to do that is somehow I'm going to have to state that triangle ABC is congruent to triangle CBD. Somehow I'm going to have to claim that triangle number 1 is congruent to triangle number 2. And then once I do that, once I state that, then I can state that A is congruent to C because they're corresponding angles in congruent triangles. And once we state that triangles are congruent, we know all of their corresponding parts are congruent. So how can I prove these two triangles are congruent? Well, I know one thing I can definitely state is angle 1 is congruent to angle 2, right? Because they're both right angles. So I know I can state that. Hey, I know what else I can state. I could also state that BD is congruent to what? BD, because they share a side. So let's see what else we have here, okay? We have a side congruent to a side, angle to an angle. What else do we have here? Now, we really can't prove anything yet, because if we state that BD is congruent to BD, look what we have. We have side, side, angle. And students, nowhere have we learned side, side, angle. Hey, I just had a thought. See this big triangle right here? Everybody see that? Everybody see that big triangle? Notice how this side is congruent to this side? Didn't we learn that in a triangle, if two sides are congruent, their opposite angles are congruent? Yes, we learned that. So if this side is congruent to this side, then go straight across, that means this angle here is congruent to this angle here. We learned that in the theorem. So we can, as we're brainstorming here, we can definitely state that angle A is congruent to angle C. We can do that. Hey, that's going to work great. If I can state all of that, look what I have. I have angle, angle, side, congruent to angle, angle, side. So I can state this by angle, angle, side. So somehow in my proof over here, I've got to get all these things listed, okay? And then after I do that, I can then state that my triangles are congruent by angle, angle, side, and then I can state that angle A is congruent to angle C. So here we go. So let's see. Um, I've got to state somewhere one of these. I'm going to start off with an easy one. BD is congruent to BD. Check that off. Exit off. There, I've stated that. And what's my reason? Well, BD congruent to BD, that's going to be reflexive property. Okay? Now let's go on. Let's state something else here. Let's state that angle 1 is congruent to angle 2. So angle 1 is congruent to angle 2. What reason would I give for that? Well, notice what I have in my given. Angles 1 and 2 are what? Right angles. And so I know that I have a postulate or a theorem that states all right angles are what? Congruent. Now, let's state angle A is congruent to angle C. So angle A is congruent to angle C. Now, do you remember how we can say that? Remember, this side here is congruent to this side here, so the opposite angles are congruent. Now, I'm going to paraphrase it, and you can do the same thing on a test or a quiz. I'm just going to say angles opposite congruent sides are congruent. And that's the truth. That's exactly right. Angles that are opposite congruent sides are congruent. And that's true. That's exactly how I can state that. So look, I've stated all three of these. So now that I've stated all three of these, I have angle, angle, side. So now I can state right here for number 5, triangle ABC is congruent to triangle CBD. And the reason would be, let's see. You know what? I have ABC. I apologize, students. It's not ABC, is it? It's ABD, CBD. I'm sorry. It'd be ABD up here. I'm sorry about that. See? ABD. Triangle ABD, triangle CBD. So this should be a D right here. I apologize. Okay, so triangle ABD is congruent to triangle CBD. By what reason? Well, I set it up here earlier when I brainstormed angle, angle, side. So I have a question for you, yes or no. Did I state that these two triangles are congruent? Yes, I did. So now, yes or no, can I state that A is congruent to C? Well, let's see. What's your first letter right here? A. What's your first letter over here? C. So yes, definitely. Angle A is congruent to angle C. And what's the reason for that? CPCTC. Corresponding parts of congruent triangles are congruent. Okay? 2 more to go. So hang in there, guys. I know you're probably getting irritated, but we're almost done. Now, usually you pick up your given and you put it on the drawing, but they've already put the given on the drawing. So next we go ahead and put our statement and our reason chart here. Okay? And then next we kind of go ahead and put our given here. So we are given that, now look what you're given. You're given that JK is parallel to MN. Do you see that? They have an arrow here and an arrow here. So we're given that JK is parallel to MN. All right. Now, we're also told that KL has 1 slash, so KL is congruent to ML. And all of that is your given. They gave that to you. They didn't write it down, but they put it on the diagram. So now look, students, how in the world can I prove that JK is congruent to MN or NM? Well, more than likely what I'm going to have to do is state that this triangle here is congruent to this triangle here. And once I state that, then I can state that JK is congruent to MN because CPCTC. So we've got some work to do, okay? Now, let's take a look at our pictures here. First, I know that this side here is congruent to this side here. So somewhere in my proof, I'm going to have to state that KL is congruent to ML. And you say, Mr. Harrod, we already did that. You're right, we did. I'm just saying that's something that's important. Now, let's call this angle 1, and let's call that angle 2. Somewhere in the proof, we're going to have to state that angle 1 is congruent to angle 2. Because they are vertical angles, are they not? Sure they are. Most definitely. So we can definitely state that those two angles are congruent. That looks like a slash right there. It's a number 1 right here. Angle number 1. Now, look at this. Here's where it gets really hard, so please bear with me, okay? Here's a parallel line cut by a transversal. And whenever two parallel lines are cut by a transversal, alternate interior angles are congruent, okay? So this angle here is congruent to this angle here. All right, so here we go. Let's go ahead and get rid of that. So we know we can definitely state that and state that. So we can state that angle K is congruent to angle M. Now when I do that, do you not see what you have? We have angle, side, angle congruent to angle, side, angle. So we have angle, side, angle. So we can definitely state that triangle JKL is congruent to triangle. Now be careful, J came first. J has no mark, so that goes with N down here. Your second letter is K. K has 2 marks. Over here, M has 2 marks, so M comes second. And the only letter left over here would be L, angle L. So students, listen, if somehow we can get these 3 things over here in my proof, okay, then I can state these 2 triangles are congruent by what reason? This reason. And then after I state that, I can state that these 2 segments are congruent because of CPCTC. So let's get all of these worked into our proof. Now look, I already have this right here. See it? So I can cross that off. I can definitely very quickly state that angle 1 is congruent to angle 2. And what's the reason? Well, we have a postulate or theorem or corollary that states that vertical angles are what? Congruent. Okay? Now moving on to number 3. So let's cross that off. Now I've got to state that K is congruent to M. Well, I can do that. Angle K is congruent to angle M. Now I can state that because, are you ready? Alternate interior angles are congruent. Now I know there's more to the theorem than that. I know it says something like, if 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. But I'm the type of teacher, I'll let you put little phrases like that. As long as you're telling me that you know what you're doing, that's good enough. So how do I know that K is congruent to M? Because alternate interior angles are congruent. Now look, you've got all 3 of these in your proof. All 3 of these are in your proof. So now you're ready to state that triangle JKL is congruent to triangle NML. And what's the reason? Well, it's right up here. Angle, side, angle. Angle, side, angle. And now once you've stated that, what is our goal? Our goal is to prove that JK is congruent to NM. Can we do that? I don't know. Let's see. Be very careful. Here's JK. Here's JK, first 2 letters. And what's your first 2 letters over here? NM. So we're good. We can definitely state that JK is congruent to NM. And how can we do that? Corresponding parts of congruent triangles are congruent. One more and we're done. Hey, you might just be copying stuff and not really, let me get a drink of water, and not really understanding it. Or you might be getting it little by little. Either way, remember, I'm very reasonable on tests and quizzes, very reasonable, and you need to see these over and over because it's part of geometry, guys. This is what geometry is, okay? All right, I think it would be very wise for us to split these 2 triangles. So you do what you want in your homework, whatever helps you understand it better, but for me, it's a lot better if I split this. So I'm going to go like this, like this, and I'm actually going to get rid of this picture in just a second. So be ready for that. So this triangle here is RTQ. This triangle here is RTS. And let's see, we can state that this angle right here is congruent to this angle here. This angle is right here, and this angle is right here. Okay? And what else do we know? We know RQ is congruent to TS, so RQ is congruent to TS. And we know that this angle here is right, and we know that this angle here is a right angle. Okay? So I think we've got everything written down. I'm going to go ahead and do something here real quick. I'm going to pull all of those together. Pull it up here. And by the way, now I'm going to pull it back down here. I need to write this real quick. We're trying to prove that QT is congruent to SR. That's what we're trying to prove, okay? So let's get rid of this. Alright, put this up here. And this right here. Okay, now let's brainstorm. Let's go ahead and get our chart up here. Statements and reasons. So here's my statements. Here's my reasons over here. Alright, now, what do I have so far? Hey, you know what? I just had a thought. I don't have many of those. I noticed we had a right triangle, two right triangles. And I'll bet you I could have used this back here in problem number 15 because I had right triangles here too. Probably would have made the problem a lot easier, and I apologize. But remember, whenever you have right triangles, you can use that theorem called HL. In other words, if you have one leg congruent to one leg, and if you have one hypotenuse congruent to another hypotenuse, and I better bring that picture back real quick. You might want to look in your book. There it is right here. Do you see how these two triangles share RT? Do you see how they share RT? Do you see that? And so I'm going to pull this back down here. Do notice that, okay? So because of that, in my proof, notice I already have in my given I already know that angle Q and angle S are right angles. Okay? Not right triangles, right angles. Okay? And then I also know in my given that angle T is congruent to angle R. That's given. And then also in my given is RQ is congruent to TS. That's also in my given, okay? So there's my given. I got all of that off of the diagram, okay? And we're trying to prove this right here, okay? Now look. I have right triangles, okay? So I definitely have got to state somewhere that I have right triangles. So somewhere I'm going to have to state that in my proof. I'm also going to have to state that I have a leg congruent to a leg. Well, I've got that right here, guys. RQ is congruent to ST. It's already stated right here. RQ congruent to TS. Do you see it? It's my given. I've also got to state that I have a hypotenuse congruent to a hypotenuse. Well, don't I have that right here? Remember when I pulled the diagram up and I showed you that both triangles are sharing a side? They're both sharing RT. So I know that RT is congruent to RT. So if I can somehow get these things into my proof, then I can definitely use hypotenuse leg to state that these two triangles are congruent. And once I state these two triangles are congruent, I can then state that QT is congruent to SR. So here's my given. So for step 2, you know what I'm going to put? I'm going to put triangles RTQ and let's see, RTQ and TRS are what? They're right triangles. Now, Mr. Art, how do you know that? Because look at your given. What did I say about angle Q? It's a right angle. What did I say about angle S? It's a right angle. That was given to me. So how can I state that I have right triangles? Definition of a right triangle. I mean, what is it? What is the definition of a right triangle? The definition of a right triangle is a triangle that has one right angle. And I have a triangle with one right angle, and I have a triangle with one right angle. So see these three things I circled? Did I just state that I have right triangles right here? Yes, I did. So cross that off. Next, I've got to state that I have a leg congruent to a leg. Well, that's already stated right here in my given. RQ is a leg. TS is a leg. So I have a leg congruent to a leg. And so because I have a leg congruent to a leg, I've already done that. Now, I've got to state that my hypotenuse is congruent to my hypotenuse. Well, here's my hypotenuse. Here's my hypotenuse. Well, that's easy. They share the same side. So I can definitely state that RT is congruent to RT. RT congruent to RT, remember, we call that the reflexive property. Reflexive. You're stating the same thing's congruent to the same thing. Now, so that's taken care of. So have I put all three of these things into my proof? Yes. So what am I ready to state now? I'm ready to use hypotenuse leg, and I'm ready to state that triangle RTQ is congruent to triangle TRS. And what is my reason? How can I do that? Hypotenuse leg. Remember, I stated that I have two right triangles right here. I stated that a leg is congruent to a leg right here. I stated that the hypotenuse is congruent to the hypotenuse right here. Everything I stated, I gave a reason. So now I'm ready to state that my two triangles are congruent. And they definitely are. Now, what am I trying to prove? That QT is congruent to SR. Can I do that? Well, let's see. Here's QT right here, the last two letters, and here's RS, the last two letters. So definitely, I can definitely say, it's kind of not a lot of room here, but I'll write real small. So definitely for step 5, I can state that QT is congruent to SR. Definitely. Last two letters, last two letters. QT is congruent to SR, and of course the reason for that is corresponding parts of congruent triangles are congruent. CPCTC. Wow, that's a homework assignment. I'm feeling your pain. I love y'all. You know that. I've told you that many times. I care about you. I hope this homework help video has been a help to you. Just continue to work hard on these proofs. And remember, I will be very reasonable on tests and quizzes.